In this section, you'll learn how to add and subtract radicals, as well as multiply radicals using the distributive property. The first thing that you need to know is that radicals are like terms when the number under the radical sign is exactly the same. So just like with regular like terms, say 3x and 2x, since their variable pieces match exactly, you're allowed to either add or subtract, and you do so by adding or subtracting the coefficients, and the variable doesn't change. The same thing would happen with radicals. So first, the number under the radical needs to be exactly the same. So here, 4 radical 10 and negative 9 radical 10, and technically it's a negative because you could do plus negative, they are like terms because they both have radical 10. So we're going to add their coefficients, which would be 4 and negative 9. So that adds to negative 5. And then you just keep the radical 10. Just like up here, 2x plus 3x is just 5x. You still have x's, you just have 5 of them. Here you still have radical 10, you just have negative 5 of them. And then nothing matches radical 13, so I'm going to say plus radical 13. So negative 5 radical 10 plus radical 13. So you're still adding the coefficients of like terms, and the radical itself doesn't change. So on this next example, we have 5 radical 3 and radical 48. So since this is a radical 3 and this is a radical 48, they don't match. They're not like terms. But radical 48 can be simplified because it has a perfect square factor. So I'm going to keep 5 radical 3. I'm going to break radical 48 up into radical 16 and radical 3. Keep in mind, it could also be broken up into 4 and 12, but then 12 would have to be broken down again. So I want to use the biggest perfect square factor, which is 16. So I have 5 radical 3 plus 4 radical 3, because the square root of 16 is 4. So by simplifying radical 48, I now have like terms because I have radical 3's. So I add my coefficients, 5 and 4, and I end with 9 radical 3. And again, the radical does not change when you add them. This would be like one person having 5 radical 3's. This is another person having 4 radical 3's. They still have the same object, which is radical 3. There are just 9 of them. You're going to pause the video and try the next 3 examples. Press play when you're ready to check your answers. So on the first example, you have 3 terms. 2 of them are like 7 radical 14 and negative 4 radical 14, which combine to get 3 radical 14, and you just keep your radical 21. On this problem, they're not like terms, they don't match, but you can simplify 63 into the square root of 9 and the square root of 7. The square root of 9 is 3, but that would multiply the 3 that's already sitting outside. So that would simplify to 9 radical 7, and then you can add that to the 2 radical 7, getting 11 radical 7. On the last example, you already have 2 radical 7. 28 can be split up into 4 and 7. The square root of 4 is 2. So now you have like terms because they both have a radical 7. Add the coefficients. 2 plus 2 is 4. Keep the square root of 7. 4 radical 7. So in this first example, you're going to be distributing. So you're distributing radical 5 to 4. And then you're also distributing radical 5 to radical 20. So since radical 5 is inside the radical and 4 is outside, I can't actually multiply the 4 and the 5 together. So the best that I can do is make it 4 radical 5. I would bring down my minus. And since 5 and 20 are both inside the radical, I can actually multiply them together to get radical 100. I don't have like terms, but I can simplify radical 100 to minus 10. So 4 radical 5 minus 10. On this example down here, because we have back-to-back parentheses, that implies multiplication. So we're actually going to use a process called FOIL to do this. So like up here when you distributed radical 5, you're just multiplying. Essentially down here, we're going to be distributing twice. FOIL is just an acronym to help us determine what order to do it. So F stands for first. So if you look at this set of parentheses, the square root of 7 comes first. And then if you look at this set of parentheses, the square root of 7 also comes first. So I'm going to multiply radical 7 by radical 7. And since both 7's are inside, I can multiply together and get radical 49. Before I go any further, I'm actually going to make this plus negative. I think it'll be helpful in the long run. And now I'm going to move on to the O in FOIL. And just to color code, I'm going to make it red. And O means outer. So if you look at this entire problem, I want to do the 2 things that are on the outermost edges, which would be radical 7 and negative 3 radical 2. And I'm going to bring down a plus sign. Just like up here, I brought down a minus sign because that's what was separating here. I've changed this all to plus on purpose, so I don't have to really think about it. And so now I'm going to multiply my outer edges, which are radical 7 and negative 3 radical 2. So I'm going to have a negative 3 radical 14. and that's because 7 and 2 are both inside the radical, so I can actually multiply them together. So now I'm going to move on to my I in FOIL, which is going to be inner, which if you look at the entire problem, I want to choose the innermost two pieces, which would be radical 2 and radical 7. But actually, before I go any further, you can see that this radical 7 just got distributed to both pieces on the other side. So really, we're just distributing twice. So now I'm doing inner, which would be radical 2 times radical 7. So I'm going to bring down my plus sign, which would be radical 14. And now I'm going to go to last. That's what the L stands in FOIL. So radical 2 comes last, and negative 3 radical 2 comes last. So I'm going to multiply those and bring down my plus sign, and I'm going to get negative 3 radical 4. So again, FOIL is first, outer, inner, last. So really you're just distributing twice. Radical 7 got distributed, radical 2 got distributed. I definitely think it's helpful to change any minuses to plus negatives before you begin. Now that we've completed FOIL, we're going to see if we can simplify. So the square root of 49 would just be 7 plus negative 3 radical 14 and radical 14 are like terms because they both have a radical 14, and I'm going to combine their coefficients, which are negative 3, and technically this is a 1, so negative 3 plus 1 would be negative 2, so I have negative 2 radical 14, and then negative 3 times the square root of 4, well, the square root of 4 is 2, 2 times negative 3 would be negative 6, and now I have one more set of like terms. I can combine 7 and negative 6 to get a positive 1. So my final answer would be negative 1 plus negative 2 radical 14. So you're going to pause the video and try the two examples that I skipped. This example in the upper right where you're just doing basic distributing, and this example down here where you'll be foiling. Press play when you're ready to check your answers. So in this first example, if you distribute a square root of 3, you get 2 radical 3 plus the square root of 36, but the square root of 36 is 6, so 2 radical 3 plus 6. Down here I color-coded to FOIL, so first would be radical 2 times radical 2, radical 4, which is 2. Then outer would be radical 2 times negative 3 radical 5, which would be negative 3 radical 10. Inner is radical 5 times radical 2, which is radical 10. And then last would be radical 5 times negative 3 radical 5, which would be negative 3 radical 25. But the square root of 5 is 5. 5 times negative 3 would be negative 15. You also have like terms here because they both have radical 10. The coefficient is negative 3 plus 1. Negative 3 plus 1 is negative 2. Then you can combine like terms again. 2 plus negative 15 would be negative 13 plus negative 2 radical 10.